This meeting is being recorded.
Hello to everyone and welcome to today's virtual event on energy sustainability with Catalyst Center. My name is Tanner Swift and I'll be your host for today's session. I'm excited to introduce an incredible speaker for you today, but before I hand the mic over to our presenter, we do have a few housekeeping items to cover about this presentation. Today's virtual event will be recorded and made available on demand after the live session, and the playback will also be available on YouTube for rewatch as well. We'll provide you with some further details at the end of today's event. Also, we'd love to hear from you during today's presentation. During the session, if you have any questions for our presenter, you can submit those through the Q&A panel here on WebEx, where we will answer your questions live or during the Q&A portion of today's event. We'll also have a few poll questions for you to participate in via Slido during today's session. So be on the lookout for either links in the chat screen or a couple QR codes during today's presentation as well, including the Slido panel here in WebEx to answer those questions you can also participate in. So without further ado, I'd like to welcome our speaker for you today, who is excited to discuss how Catalyst Center can enhance your energy optimization. We'll kick things off by first sending it over to Casey. Casey, right over to you.
All right, thank you, Tanner. Hello, everybody. As Tanner mentioned, my name is Casey. I'm going to be going through energy optimization and sustainability with Catalyst Center during this session. We're going to go into both the wired and the wireless end. I'm going to show you a few ways to implement energy sustainability. And also, we'll go and look at how you can monitor energy sustainability to optimize it further. So we're going to cover each of these. There's going to be 3 demos, one for wired, one for wireless implementation, and then one for monitoring as well. We're going to dive a little bit into our reporting too on that. All right, so the first poll, Tanner, I'm going to hand this off to you.
Sure. We got, as mentioned at the top of the event, a few poll questions for you to participate in today. Our first poll question for you, we'd just like to know, what version of Catalyst Center are you currently running? You can use the QR code on your screen, the Slido panel here on WebEx, or I'll place a link in the chat screen momentarily to provide that. And Casey will recap some of those answers near the end of today's session.
All right, thank you, Tanner. So I'll go ahead and here's the agenda. I basically just went over it. We're implementing energy optimization on switches, wireless, and how to use it and monitor it. Now, before we dive in, I'm going to give you a high-level overview of both wired and wireless for energy optimization. So let's start with a high-level overview and begin with wired. So first off, one of the really neat features is stack power. As you're aware, if you haven't heard of it, heard of stack power, traditionally, how switches get power is they connect to a central device for power management. And what that does is it consumes a lot of physical space, a lot of resources, and they're all sharing the same power resource, and it's not very central. It's somewhat central, but it could be better. And this is what stack power does. It allows one switch to connect to a power outlet, power device, and then it basically allows diversification. It allows distribution of power from that switch that's connected to the power outlet, and it allows, similar to like a daisy chain, if you can think of like a or a stack with Ethernet cables for switches. It's a similar type of thing that also introduces redundancy of power as well. And we're going to look into this visually what that looks like in just a second. But for now, I just wanted to give you a high-level overview of that. We also have energy efficient Ethernet, which allows you to say, power down different ports or reduce energy when, say, during non-active periods. Say you want the port to go idle or something like that. We're going to go into what's required for this and how to implement it and what you get for this as well. And lastly, for wired, we're going to go into embedded event manager, which is basically, we're going to do this in the demo as well, but what you'll be able to do is you can write scripts within your Catalyst Center switches, and it can react to various events, and it could, say, turn off different ports, different energy ports at certain periods of time. and stuff like that. You can get very creative with what you use Embedded Event Manager for, but for the purposes of energy management, there's a lot of things you can do for here. The specific example we're going to focus on is managing it based on time. Let's say we're doing like a 9 to 5 work week, right? And we don't want to consume as much power at 5 when the day is over. So we can get those switches to dynamically adjust the amount of power and we can completely turn off the ports at specific periods of time to conserve energy. Okay, next slide, I'm going to do a little high-level overview of the wireless end. One of them is you can refresh energy of efficient APs. So this involves Catalyst Wi-Fi 6 and 6E. Our APs are on average 53% more efficient than older generations. We'll see why specifically this happens. Catalyst Center Wi-Fi 6 and 6E APs have the highest power efficiency in the market currently. Of course, Wi-Fi 7 is following here after. It's coming out soon. Now, optimization of AP power, use power save mode to turn off AP features when they're not required. You can use AP power distribution to allocate AP resources at reduced power levels, and reducing AP function during off-peak hours could save an additional 20% energy cost compared to regular idle mode. So we're going to do a demo on this as well, and it's going to be involving creating AP power profiles to dynamically adjust the power of the radios, the antennas over periods of time. And then lastly, we're going to go into the dashboards and reporting and monitoring and seeing how all the information we can get related to both Wi-Fi 6, but then also non-Wi-Fi 6 devices, and see how we can optimize it, including generating flexible reports across various intents. So like we could create reports based off of trends and correlations. We could create reports based off of top performing APs, stuff like that. Okay, so that's it for my high level overview. Next, I'm going to go into implementing energy optimization for wired switches. We'll start with stack power. Stack power can reduce the number of power supplies required per switch and the number of power outlets and cooling requirements in the wiring closet, right? Because there's less power coming straight from these universalized power outlets. It's now being shared amongst the switches, so the cooling cost goes down as well. We have aggregated loads that allow power supplies to operate at optimum efficiency, considerably reducing the waste of power over time. Okay, so this is what it looks like traditionally. This is probably what you're used to. We have a power set. These are the switches: PS1, 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 and it connects up over here. Here we have a redundant power supply. What Stackwise is we can see somewhat of a daisy chain in a way, a redundancy, where these are our switches. There's 4 right here. We have our PS1 or PS2 right here. The PS2 is supplying redundancy. So if, let's say, for instance, a switch in stack 3 went out, if it went out, this loop right here would add redundancy to the rest of the stack. So it'd take it would take this switch to go out completely as well. If this switch lost power to this link, this switch would have to go down as well in order for it to lose power. So there's redundancy in all avenues of it, and the switches are sharing power capabilities as well. Okay. The next is stack power provides redundant power system, RPS, functionally with 0 RPS footprint, pay-as-you-go architecture similar to the data stack, where you can do daisy chaining, 1+N redundancy with inline power. You can have up to 4 switches in stack power ring. Now you can have up to 8 in the star topology. You need to use an expandable power system or XPS to do this, but it's definitely possible. And then multiple stack power, multiple stack powers. So you can have up to 8 switches if you use XPS. Now, this is kind of visually what it looks like. We can think of each switches, they may have different wattage requirements and everything. And we have our 4 switches and our power allocation pool. So this is a pool, and these are switch 1, switch 2, switch 3, and switch 4. All have different watts. They're all sharing power within this pool, and it's being allocated in accordance with which switch needs a certain amount of watts. Okay, and next is the cable. There's a specific cable for this, and the cable shown connects it connects to a Cisco 9300 series switch to another 9300 series switch and a power stack, or to an XPS 2200. The XPS again is to extend beyond a 4 stack to an 8 stack. So it has a green band on one end and a yellow band on the other. The cable with the green band can connect only to Catalyst 9300 series switches. The cable on the yellow end can connect to 9300 switch or other devices. In this example, we're just talking about 9300 switch, but it can other devices that support it as well. And XPS 2200. So if you're going to use, if you want 8 switches, you need to connect the yellow part to the XPS 2200. However, the yellow part is multifunctional. It can operate as if it was connecting to a switch as well. All right, so hardware installation visually, this is what it looks like on the actual switch. We can see the links are going, they're daisy chained here. We have you can barely see it, but it's like we have our green and our yellow bands right here. Here we're not using the XPS, it's using the 4 switch max, but it's getting the redundancy and the power optimization from how it's connected right here. Next, we have our energy efficient Ethernet, which reduces power consumption during periods of low link utilization while the port remains up. Both devices on link must support 802.3 AZ for it to work. So make sure that is supported for your devices. And if supported, LDP can be used to select optimal parameters for both devices. Now, this is what the data will look like. We have our active data. It's going to be either data's in transmit, data's at idle. It has flags for sleep, where it goes quiet. It has flags for refreshing, and it has flags for waking and idle as well. So it uses this. This is how it'll flag the port. And we can get a little bit more specific, as we'll see in Embedded Event Manager in our demo, where we can actually control this through Embedded Event Manager. But right here, what we're doing is we're getting energy efficient Ethernet. This is how to configure it. Again, you need 802.3 AZ for it to work. To configure it, it's simple. You just go to Configure Terminal, interface gigabit Ethernet 1022 in this example, and then all you have to do is power efficient Ethernet auto. So the main requirements are, it needs to support 802.3 AZ. You need cables, the right cables for it, and it needs the ports available. And then all you have to do to configure it is this. Once configured, all you need to do is verify that it's working. So you'll do show EEE capabilities interface G1022. We can see that it is enabled at this point. This is what we're expecting. It's operational, and its current status is set to low power. Okay, and next we have our Embedded Event Manager. Embedded Event Manager is contained within the local device itself. It provides inbox monitoring of components using software agents, aka event detectors. EDs notify EEM when events of interest occur for action to be taken. So if X happens, then I do this, is how it works. EEM policies configured using applets, CLI-based, or scripts, TCL-based. Here's an example of this. In this example, an EEM policy applet CLI-based shows how device PoE ports are scheduled for power off and power on daily between 5 p.m. and 8 a.m. using the EEM timer ED. So let me break this down. We have Event Manager applet selective power service off. All right, here I'm specifying the time, 0 through 17, specifying the time. So if it's this time, Then if this event happens, then, and you can get very creative with this, this is that we're just working at the timer here, but if it's this time, then switch, go into enable, show power inline, CLI result. Then here I'm doing a regex command, so it's going through the gigabit numbers. So here it's selecting the gigabit, it's a random gigabits. This is a dot star, which means and on line, and then it matches interface. So it's turning on the line at this time. So between 0 and 17, it'll turn it. I'm sorry, it turns it off. And then we have regex result, and it does a contt interface, and then we have, this is a variable for the number that'll go in. Power inline never, this is turning it off. Then we have an optional message that you can put in, turned off PoE on interface. Okay, now what we have is, and I do want to go back and reiterate, this is checking if it's on to turn it off. I think I misspoke there. This is checking if it's on to turn it off. Now, this is when we're turning it on. It's checking if it's off to turn it on. So two conditions are being met. Right here, we have the 0 and 8 time. So this is being met, and it's off. Therefore, I want it on during this time. So it's off currently. And then I go in, power inline auto, turns it on. And then we have a message, turn on PoE interface. Okay, now it's a lot. You might be thinking, how do I have to implement this on one switch at a time? No. The nice thing about Catalyst Center is, and this is out of the scope of this presentation, but what you can do is you can use, you may be familiar with it already. It used to be called Template Hub. Now it's called Template Editor. Then it was called, no, first it was called Template Editor. Now it's called Template Hub. We've moved it to CLI Editor, and it's under the design section now. And this is because we need to get it closer to network profiles because they tie in very much with that. It's relocated over to that. And what you can do through that is you can configure this base template, something like this. You can configure your, and you don't, it doesn't have to be limited to just time, but you can configure your entire profile and then assign it to the network profile. And then what you can do is implement it to a wide majority of switches. So not only one switch, not two switches, but let's say we have a site in, for instance, London, and we have 1,000 switches under that site. We can add this, create this in a CLI editor within Catalyst Center, save it, commit it, apply it to a network profile that is under London site where all the switches are under, and then we can provision that to all the switches. And then we've automated the power optimization through embedded event manager based on our intent. Again, that's out of the scope of this, but we may have a session coming up, and I would say about 4 months from now, because as you'll see at the end of this presentation, we do have a few more planned coming up, but we'll have one coming up about PNP. Definitely check out Plug and Play and CLI Editor and version release 2.3.7.6 for Catalyst Center, and that'll explain more about it as well. Okay, so now I'm going to go into a demo of EEM on Catalyst Center. I'm gonna pull this up, and I am currently logged into an edge switch. And let's go ahead and do a show run. I'm just going to verify and make sure that, you know, EEM is not configured. It's not configured. We checked event manager. It's nothing showing right now. So we're at a good state. Now, what I have is basically what I just showed you. It's the configuration for powering off and powering on a device at a specific time. So we'll do a conf T. I'm going to copy this in, copy paste it in, implement it. And we're gonna do some verification, make sure it's working, show run. And now we have our event manager in here. So it's basically just a little script. It's a sequence script of conditionals. Okay, show power inline. We can see that, all right, gigabyte 103 is on. There's an AP connected to it. And here we have a switch connected to this port as well, and it's on, okay? Now, what we want to do is we want to trigger an event. Okay. So I'm going to do event manager run. Yeah, select power off. Okay. The thing is, we don't, since we're limited on time, we don't want to wait for a long period of time. And what happened right now is it's saying service power off is not registered with event none event detector. What this means is that it's not the correct time in order for it to power off the switches. It's detecting that the condition hasn't been met. Okay, but there's a workaround we can do. I'm going to show you for demonstration. Event none. What this does is it allows us to manually trigger. It allows us to manually trigger rather than wait the full extended period of time for this. So now let's go ahead and trigger it. Do terminal monitor so we can see the events happening in real time. Now we're going to do event manager run. Selected service power off. We can see that it turned PoE off. It turned the port off. Shut it down. Do a show power inline, verifying it's off. No devices connected to it. I'm going to do a show run interface 203. Power inline never. That should be power inline auto if it is on. Switch it to power inline never. We're doing a terminal no monitor, turning that off. Event manager show run. Now we're going to power it back on. And show power inline. We can see it's on IEEE PD. So it's powered back on. It's still getting the device name and information, but it is working. And we still have our event nuns in here. I'm just gonna copy that back in, our old script back in, which is actually gonna override it. Those event nuns. It's not, you don't have to do like a no event none. This is like an easier way to do it. It kind of works like an access list in a way when you implement it. But so event none, because really what we want to do is we want to have this automatic, right, based off of time. But that was just to show you so we could trigger it. But right now, we have it set back to the automatic timer. Okay, so that is it for embedded event manager. I'm going to go ahead and go back to the deck, and we have a few more demos after this. Next, let's go into wireless, implementing energy optimization with wireless. So the first method, we have our AP power save mode. What this does is we can lower AP power usage. We do this by tuning radios. So we can create a calendar profile for off-peak hours, so weekends or nighttime if needed. We can create a power profile to lower the power consumption budget during off-peak hours, and it can do things such as shut an AP radio down, lower spatial stream, lower the port speed, disable the USB port. You can see we have multiple policies here. Here we have a monthly policy, the second, third, the fourth, the fifth, so on and so forth. We have daily, we have weekly, Monday, Tuesday, Wednesday, Thursday, Friday. So this is when obviously the work week is operational, and we have a specified time for disabling ports. And it looks, as you can see, it's about 6 o'clock at night, all the way to here. Makes sense. Monthly, we have our start time at 8 p.m. And then here we have for daily, this is this is a back because of course at 12 o'clock it'll hit the it's midnight, right? So this is a continuation of this daily right here in the morning. So that's how AP power save mode works. We're going to actually dive into this in the demo to explain it a little bit further. Okay. AP power distribution. Control how power is used and reallocate extra AP power to different radios while operating on PoE plus. 30 watts. When you hear PoE plus, just think 30 watts. So you can allocate extra AP power to radios if you have this. If the AP supports PoE plus, which is giving it 30 watts, you can take energy from one radio and max it out on another radio if needed, which can help a lot with speed and performance and things like that. We have an example. You can disable 2.4 gigahertz radio and use extra power on the 6 gigahertz radio with PoE plus. And then we have our power profiles, so you can control the speed. Example, you can have a from 4x4 to 1x1 spatial stream here. If I go down here, we can see what we're working with. Like we can work with the interface of the AP itself that's using PoE. We can use we can work with our radios, and the interface. Basically, what we're doing is we're doing an interface ID. And we're giving it the parameter speed, 1,000 megabits per second. If I go in deeper to this, as we'll see in the demo as well, this is based off of time. So this is being executed at a certain period of time. These are actions tied to an AP profile. These are power profiles tied to an AP profile. All right, and these will be implemented at the time that's specified within that profile. We'll see that further, so it makes sense in just a second. The radio is here. We have a 2.4 gigahertz radio, and the parameter is state disabled. So it'll disable the state of a 2.4 gigahertz radio at the specified time. And for the 6 gigahertz, we have spatial stream 1x1 to increase performance. Okay, so that's AP power distribution. Take a quick second to hand it back over to Tanner so he can do poll number 2.
Of course. Just as a quick reminder, if you wouldn't mind participating in some poll questions that we have for you today, you can use the QR code here on your screen and or the Slido panel here on WebEx. Poll question number 2 for you. What type of networks are you currently optimized for energy sustainability with Catalyst Center? Wired, wireless, or both? Or currently an energy sustainability solution is not implemented? We'll have one more poll question. We'll get back to you here in a little bit. I'm going to kick it right back over to Casey to continue the session.
Thank you, Tanner. All right. So with that, let's jump into the next demo, configuring AP power profiles with Catalyst Center. Okay, so now we're focusing more on the wireless end. Let me pull this demo up. Okay. All right, so I'm in Catalyst Center right now. I'm going to go ahead and click the menu, and I'm going to go to Design. Now, network settings. Then we're going to go to wireless. All things wireless. This is where you configure everything. But we're going to be focusing specifically on AP profiles and power profiles. So here's an AP profile. I'm going to click Add Profile for iOS XE, and I'm going to give it a name. Here, I'm just going to call it Super AP Profile. Can be generic, just as long as you recognize it. And we have a few options here. We'll be back to here later to go over the different options, but for now, we're just creating the profile. Next, after we're going to go create the power profile. So we'll click Power Profile, and we'll click Add. And we're going to give it the name Night Power Profile. All right, so we're going to create a few rules here. And click Interface, Ethernet, Gigabit, Ethernet 0. I'm going to tune it down, 100 megabits per second. So we're conserving a lot of energy here. We're limiting the amount that it can have. 6 gigahertz, the radio, so this applies to 6 gigahertz. We're going to set the state to disable for 6 gigahertz. Okay. And we're going to go click 5 gigahertz spatial. We're going to click state and then disable here. So we're disabling both the 5 gigahertz and the 6 gigahertz. We're going to specify the time in just a second, but for now, we just configured the AP profile. Now, let's go back to AP profiles. We just configured the power profile. Now we're going to go back to AP profile and check the left side and then click Edit. Okay. Now we're back to where we were earlier. We can dive into a lot of tabs, security, things like that. But for this demo, we're going to focus on the power tab. We're going to select the profile we just created, night power profile. So we're assigning it to the AP profile, and then we're going to now specify the time. So we have a power profile and an AP profile. The AP profile is going to handle a bunch of stuff, security, management, but we need a power profile to apply it to a centralized profile that can be deployed to the APs, and that's why this is done. So we select our AP power profile, and here we're defining it weekly. So it's going to run weekly at these specified days and the time. And then we get a little map here of like what times it's going to go ahead and implement what we did. Okay. Next, I'm going to go ahead and select night power profile weekly. This time, we're going to do the weekend. So I'm going to select off for this. So we have Saturday and Sunday. And I'll give it a time, 12 a.m. 11:59 p.m. So all day, Saturday and Sunday. And then we'll click save. Looks good. And I'll click save. You can see that it's enabled. 3 power profiles are applied to it. If we wanted to, we could apply a network profile to get even more granular, but that is how you configure them. One thing is, if you're once you do that, they're not configured on the devices yet. So power profiles and AP profiles, they're configured at a site level. So depending on the site, let's say for instance, I had a site London, and I had network devices under that site, APs under that site, I would need to go and provision this to those APs. Okay. Otherwise, it's not going to be there. So we have it configured on Catalyst Center, but in order to provision it, I need to go to Inventory, Provision, click on the devices, and then provision it. And then it'll be on the APs at that point. Okay. All right, so the next thing is using energy optimization with Catalyst Center. Now we're getting more so, we've discussed implementation. Now we're getting more so into the monitoring aspect of PoE. So here's the, and wireless. The PoE dashboard. This is a PoE dashboard, and it's under the assurance. If you go in Catalyst Center, you click the menu icon, you go to assurance PoE, and it will show you the various dashboards you can get from here. And here you can get a lot of insights. Here we have estimated AP power savings. We have our AP power save mode distribution, so how it's being distributed. We have our PoE insights. Here we can see that 100% of power devices are not enabled for perpetual PoE. So this is giving us insights. Hey, how can we monitor our sustainability in Catalyst Center and our infrastructure? And if you don't have it currently implemented, you can still go to this monitoring dashboard. And this may give you a really good suggestion on how to actually implement this. So you go to Assurance PoE, you can see, hey, I don't have all of my devices aren't enabled for PoE, for power saving functionality. That might look into how I could do that, which Catalyst Center can help you implement. And then we have our PoE operational state distribution. So right now we have 69 devices that are powered on. Could potentially be that, we're not, there's some devices that don't need to be powered on right now. And we could get into that. Another thing you can use, if you're familiar with Cisco Spaces, you can identify, Cisco Spaces is really good for detecting peak times of business. Say you have a store, and it integrates with Catalyst Center. So we can see when devices, we can scale down the amount of devices that need to be used at specific periods of time based off of insights that you could use with Cisco Spaces, telling you which devices are currently in use or not. The PoE operational state distribution, you can use that in conjunction with Spaces to really dial in your sustainability goals. Okay, so we have PoE powered device distribution right here, PoE port availability, used ports, free ports, just giving you an idea of, capacity. We have our pallet allocation load distribution, power usage, our total budget. So PoE power allocation, system power allocation, available port power, it's all defined here. It's currently at 740 watts. And then we have our PoE AP power mode distribution. So right now we have fully powered 51 APs, 0 are partially powered or unknown. So right now, this is telling us we don't have sustainability implemented. It's observing this, it's seeing devices that don't have sustainability implemented, but ideally we would want to shift these numbers a bit. So there's a good starting point if you're here. Okay, next I'd like to take a brief moment to talk about Wi-Fi 6 and 6E readiness. This isn't a presentation on Wi-Fi 6 necessarily, so we're not going to go in depth here, but I do want to share with you the various components that it can offer for you. We do have a Wi-Fi 6 readiness dashboard, and as I mentioned earlier, having Wi-Fi 6 enabled for your clients and APs, it significantly reduces the power consumption of your wireless network. Okay, so we can see here where insights, it's collecting, Catalyst Center is collecting insights. 71.77% of clients in the network are Wi-Fi 6 capable. 26.28% of your AP infrastructures is Wi-Fi 6 ready. So it's giving you a heads up, kind of like what we did on the last dashboard, of how we might go about implementing this. If Wi-Fi 6 is not enabled yet, and we have a lot of clients that are ready to use it, we can transition over to that. Here we can see client distribution by capability. 36% of Wi-Fi clients are associated to a Wi-Fi 6 network. So here we have our client list, Wi-Fi 6, and then we have our other networks as well. And then we have our network readiness. It gives us a breakdown of our network readiness for our AP. So this is for our clients' network readiness. This is for our AP network readiness. And then we have our AP distribution by protocol. So the various wireless protocols that are being in use right now. And you can see we have a little bit of Wi-Fi 6, but we also have a bit of other protocols being in use. So something we could think about potentially for upgrading the wireless infrastructure hardware, or if devices are already capable, we can go ahead and roll out Wi-Fi 6. Another really neat thing about Wi-Fi 6, it has Wi-Fi 6 uses a target wake time. It uses TWT technology, which allows devices to schedule when they wake up to send or receive data. So I'm talking clients, now they can, and APs, they get a target wake time will allow them, say it's nighttime in the morning, like right at 8 o'clock, or maybe just a little bit before 8 a.m. It wakes up and then the antennas are powered on, and then communications start. So Wi-Fi 6 is getting a lot more intelligent. And then of course, Wi-Fi 7's coming down the line. Okay. So custom reporting for PoE. Now we're getting into reporting. So those are the dashboards. We can get a little bit more specific. We can configure reports for for the last 30 days. We can do it for custom if we want to extend that time, and we can do reporting. We'll see this in the demo of how this looks, but you can send it out through email. This is beyond the scope as well, but there's various methods to receive a report. Catalyst Center can send it to a WebEx room. They can send the reports to a WebEx room. If you can create a WebEx pod, it can send it through email, and multiple means. It can send it through PagerDuty, various integrations to receive those reports. But we can get very granular with a flexible report on what kind of stuff we want to track. And this particular instance, and reports are not just limited to PoE, but this is what I'm covering here is PoE. But we can get very specific. There's a lot of metrics you can get. And this way you can, as you're implementing your power, your sustainability goals over your infrastructure, you can get weekly reports to see how it's going. And then you can optimize it and fine tune it accordingly. So we have right here, This report is more so looking into top. So the top performers, top AP performers. We can see device name, device type, location, and max power usage. So this is clearly looking at the top APs, performing APs. I'm going to go ahead and go to the demo to show you a little bit further about this. So give me just a second. All right, so I'm at Catalyst Center. I'm under reports, and then I'm click report templates and generate flexible report over here. All right, I'm going to just give it a name, POE weekly report, and last 7 days. Click next. Now we're creating a sub report. We can create multiple reports within a flexible report. Multiple reports. So we're creating a sub report within a report. We're going to create 2 here. For this, first, we're going to select POE as the entity, and the type is trend. And this is going to give us our various things we can track related to trend. There's 9 total that we can use. So I'm going to select power usage. All right, and then we're going to set an aggregate. It's average, and then we're going to click next. We can specify the location. So these are our sites within our network hierarchy. They can specify the location. In this case, we're just going to leave a default. So it's going to apply to global. So we have our trend. Would you like to create another sub report? I'm going to click yes, click next, and now we'll create another one. We'll do POE usage. By the way, you can create a report with multiple different stuff. It doesn't have to be just POE. You can do POE in software image management, stuff like that. So we have our top end. You can get some interesting correlations with that too. Like say you're doing software upgrades, you want to see how power reacts to that. That's something you could look at. All right, so now we're looking at top performing APs. We have 19 attributes total we can select from. So we'll select a few here. Max power usage, click next. All right, max power usage, we have our watts. Ascending order, that's going to show the top performing APs first. If I select ascending order, it's going to show underperforming APs. If I select descending order, I'm going to go with descending order. And this time I'm just going to select no for sub report and click next. And here's where we can say, all right, CSV file format, we're doing an email. You can create webhooks. We talked about this just a second ago, but here we're doing it via email. So it's going to send an email report out. You can use distro emails for implementation, for operations teams, distribution emails, again, WebEx. And there we're going to go ahead and generate our report. And it'll take just a little bit to generate. And again, this is scheduled for a one time, but you can schedule these frequently and it'll do it automatically and then send it to you automatically. So I'm going to download it. Remember our POE weekly report. I'm going to bring that up. And we have our top and our trend right here. First, I'm going to open the trend report. We're going to take a look at these trends. So there's a lot here. There's a lot, like how, like, you know, going through all this data would take a long time to interpret. But what we can do is we can modify a few things around doing the wizard and use a decimal separator. And then what we're going to do is we're going to format this into a table, make it a lot more easier to read. Okay, it already looks a little bit easier to read, but we're going to make it graphical. I'm going to click insert, and then I'm going to select that icon right there, the lines, and now we can see graphically how is our power usage looking over time. And here we go. And next, we're going to look at our top performing APs. In a similar approach, a little bit easier to read, but we can make it better. So we're going to format our table. Make sure you do this first so that it can make the columns and rows mapped correctly. Okay. Now that we have that, we'll click insert. This time we're going to do a bar graph. So I'm gonna click bar because now we're not looking at trends. We're looking at top APs, and we can see our APs listed here. Max power usage over time. So we can see which APs are consuming the most power. And we can look into this. We can get a lot more information through Catalyst Center, even through Cisco Spaces. Maybe one AP is getting overburdened. Maybe we can even increase performance by looking at that. Maybe there's a lot of clients connecting to a particular AP at a given time. We can get a lot of trends and insights to make both our operations, our speed of our wireless networks, and our energy sustainability and optimization make it a lot better. Okay, so that is the last demo. I'm gonna go ahead and hand it back over to Tanner for poll 3.
Really appreciate it, Casey. Thank you again for the demo. We'll get to poll 3 now, which is live for you to provide your responses on how likely are you to implement an energy sustainability solution in your environment. Very likely, not likely. I already have an energy sustainability solution implemented. We'll get back to these questions soon and read you the results. And Casey, back to you in the meantime.
All right, thank you. I'm gonna finish up with a few key points to remember. First, stack power enables aggregated loads, which allows power supplies to operate at optimum efficiency, considerably reducing the waste of power over time. 802.3 AZ reduces power consumption on low utilization ports. Both devices must support 802.3 AZ. This is for the PoE. Then we have Embedded Event Manager. EEM resides within the local devices, and it communicates with event detectors, which monitors events of interest. And lastly, AP Power Save Mode enables you to create profiles to conserve energy of the APs during off-peak hours and utilize AP power distribution to control how power is used amongst various wireless bands. All right, I'm going to go ahead and hand it over to Tanner for the final close off. Tanner, over to you.
Thanks so much, Casey. Really incredible job today. Thanks so much. We have reached our Q&A portion of today's event, so we will take some time for questions now. Just a reminder, if you do have a question for Casey, you can use the Q&A panel here on WebEx, and we will read your questions aloud and get a response. Before we get to any questions that might come in, Casey, I'd like to read some of the poll results back to you. Is that okay?
Yep, sounds good.
All right, let's do that. So we'll go back to our first poll question that we showed you today. What version of Catalyst Center are you currently running? 50% at this moment do not have Catalyst Center installed. 43% are at 2.3.5 or above, and just 7% at the 2.3.2-2.3.4. Our second poll question today, what type of networks are you currently optimized for energy sustainability with Catalyst Center? 47% are currently solution is not implemented, 33% with both, 13% at wired, and 7% at wireless. And then our third poll question that we just showed you a few moments ago, how likely are you to implement a energy sustainability solution in your environment? 47% are likely and 40% very likely, as opposed to the 13% that are not likely. Let's see. I do want to read this question aloud, Casey, and I want to thank Julio and Kavita for being available today as panelists, as well as answering some questions, but just want to recap something that you touched on during today's session. This question came in from Adrian, and he asked, can Catalyst Center manage the embedded event manager?
Good question. It cannot do that, but again, it can to some degree. There's no like dashboard where you can go in and like configure, like how we're configuring the AP profiles and everything. There's nothing like that. But what you can do is you could do CLI templates, right? CLI templates, and you can. And we're going to have a session on this coming up within a few months. But what it'll do is you can configure your EEM profile, and then what you'll do is you'll tie it to a network profile, which you'll then provision to. You can provision it en masse to a large scale of devices and stuff. That's the closest thing we have at this point for EEM.
Great, thanks. And then I'm going to follow up with another question here. Just to clarify, Catalyst Center was DNA Center?
Right. Yeah, it was in version 2.3.7.6, I believe, where it switched from DNA Center to Catalyst Center.
Thank you for clearing that up. That looks like at the moment that is it for our questions. Casey, I want to thank you once again, but also give you the floor once more. Is there anything else that you would like to cover before we do wrap up here?
Yes, let me just share my screen. Sorry, I stopped sharing. Let me share my screen again. I did want to cover upcoming webinars. We do have a webinar on February 12th. It's going to cover Wi-Fi 7, unified licensing with Catalyst Center and Meraki. So definitely sign up for that. The registration is not created yet, but it will be soon. Okay, and then also we're going to be starting an SDA series. It's a three-part series. The first session will be on March 12th. That's not created yet either, but it will be as the time approaches. And what we're going to do is we're going to have a getting started with SDA with Catalyst Center. There's a lot of new enhancements for SDA coming out. And then we're going to cover the new dashboard and everything. And then the second session is going to be more so advanced features. And the last session is going to be more so working and monitoring with SDA. But other than that, that's everything. I want to thank everyone for joining. I hope you got a lot out of the session and have a great day.
Beautiful. Thanks so much, Casey. And as he mentioned, for those upcoming webinars, you can register for those on the Cisco Learning Network. Those webinars will also be included in each of our monthly newsletters as well, so that you can stay on top of and register for any future webinars as well. I want to thank you once again, Casey. I would like to also thank Kavita and Julio and the whole team for bringing your knowledge to the Cisco community today. If you do have any additional questions, we'll keep that Q&A window open for a couple more minutes. For even more tutorials, demonstrations, and future webinars, please visit the Cisco Learning Network. You can follow up with any further questions, view resources from today's session, as well as its recording through the post-webinar discussion thread on the Cisco Learning Network. I've placed a link to that thread in the chat screen for you. You can also find that thread on the Cisco Learning Network as well in our forum space. At this time, you will be redirected to a post-event survey. Please take a couple moments in answering those questions, as it helps us prepare some future sessions. Once again, we thank everybody for joining us today, and we will see you next time on the Cisco Learning Network.